So we're going to look at some derivatives of logarithms today, which requires you to use some of those properties to expand and condense things. So some reminders over there on the right about your properties for expanding and condensing. If we're looking at this one, I would first probably expand it into two logarithms, one of the numerator and denominator, where you've got subtraction in between because they're being divided. And then you can make log of 2x squared into log of 2 plus log of x squared. I went ahead and brought the 2 out in front for my exponent. And then same idea with log of 3y. That would all be being subtracted, so I put some parentheses around it. And then I decided, I'm just going to flip my signs. So there we go. Okay. So first off, before we get into anything that requires expanding or condensing, let's talk about derivatives of logarithmic functions. So basically how they work is, let's say you have log base 2 of 3x. The derivative of a logarithm is 1 over the inside of your logarithm, which in this case is 3x, times natural log of the base of your logarithm, and then, if necessary, multiplied by the derivative of the inside from our chain rule. So recap, 3x was inside, so 1 over the inside, natural log of my original base, and then multiply by my derivative of the inside of my logarithm. Okay, so if you're looking at this first one here, f prime of x is just 3 times, and then doing my derivative, 1 over x times the natural log of, well, this is base e, so natural log of e, times the derivative of x, which is just 1. So we just get 3 over x. Similarly, f prime of x here is going to be 2/3 times 1 over x times natural log of 10, because this is a log base 10, times 1, which is just going to give me 2/3 and then natural log of 10 and an x in my denominator. All right, one more and then I'll have you try one. So 1 over my inside times natural log of base e times the derivative of 2x plus 1 is 2. So 2 over 2x plus 1. We're going to combine some logarithms and some chain rules. So here we're going to have to work from the outside in. So I'm going to start with 3 times natural log of x to the second, and then multiplying by the derivative of the inside, which will be 1 over x times natural log e, and then times the derivative of x is 1. So simplifying, we have 3 natural log of x squared over just plain old x. F is going to take some product rule because we're multiplying those two functions of x together. So I'm going to set this up first. So x times the derivative of natural log of x squared plus the derivative of x times natural log of x squared. And then doing the derivative, I'm going to have 1 over x squared times natural log of e times the derivative of x squared is 2x. And then I'm just going to have 1 times natural log of x squared. We could multiply some things together here. Hang on, that'd give me 2x squared on top over x squared. And then I could divide out my x squareds and just have 2 plus natural log of x squared. Okay, so sometimes if you have more complicated ones, it's easier to expand them out before you take the derivative. So we're going to do that because otherwise we have to use like chain rule inside of a logarithm, and it's just going to get kind of messy. So let's change that radical to an exponent of 1/2, and then I'll bring it out in front and multiply by it. And then it's easier to take my derivative of because I can just make it 1/2, and then my inside would be x plus 1. And then really the derivative of everything else is going to be 1. So yeah, I'm going to leave it like that. All right, this one is very, very, very horrible to do if you don't expand it. You got to use chain rule, product rule, quotient rule. Heck no. So expanding things out here, I'm just going to do it all at once. So hopefully that's okay. You're going to end up with that expression. I could expand the natural log of 2x more, but I don't feel like that really makes it any easier, so I'm not going to. So my derivative, I'll have 3 and then times 1 over, or just in the denominator, 2x minus 1 times its derivative, which is 2, and then 1/2 times 2x times its derivative, and then minus 2 over x. Simplifying just a little bit, I have 6 over 2x minus 1. I'm going to divide out a factor of 2 and just make that 1 over 2x minus 2 over x.